Okay. It says the function f is continuous on the closed interval from 0 to 2 and has the given values that are tabled above. So at 0 we're at what? 1. At 1 we don't know, and at 2 we're at 2. Yeah? So the question is, the function equaling 1/2 must have at least 2 solutions on the interval if from 0 to 2 if k equals. Meaning the function that connects this one and this one needs to equal 1/2 twice if k equals what? So what we're trying to do is how many times, or can we get f of x to equal 1/2 twice, right? So if you look at your options, okay, if I have to go from here to here to here, does that equal 1/2 at least twice? And does it have to? To go from here to here to here, do I have to cross through 1/2 twice? Then that's my answer. Because the next one's 1/2, I could just bounce off. The next one is 1, and then 2, and then 3. They're all the same. I mean, there's nothing about that that makes me have to go through 1/2 twice, like I do right there. So, 0. Okay. Let f be a function that is differentiable on the open interval from 1 to 10. If f of 2 is -5, and f of 5 is 5, and f of 9 is -5, which of the following must be true? Does f have at least 2 zeros? What are zeros? Yeah, zeros are when it crosses the x-axis. It has to have at least 2 of those. The graph has at least one horizontal tangent. Why? Okay. Yeah, I don't know exactly where it has a horizontal tangent, but I do know at some point it does have to, because it could do something like this, right? Okay. The only reason I know for sure it has to is because it says it's differentiable, right? And because this right here, the average slope is what? 0. I rise nothing, and then I run 7, right? So the slope right here is 7, or 0 over 7, which is 0. So since the average slope is 0, because this is a differentiable function, the mean value theorem says that at some point the actual slope has to equal 0. Okay, so that's mean value theorem. Okay, for some value c between 2 and 5, f of c has to equal 3. So between 2 and 5, does the function have to equal 3 sometime between there? To get from a -5 to a +5, do you have to cross through 3? Yeah, if that's 5, 4, 3, 2, 1. Looks like I have to cross it. The way I drew it, cross through 3 right there, right? Okay. Now what theorem is that? IVT, intermediate value theorem. Okay, let's talk about 3. The function f is continuous from -2 to 1 and differentiable from -2 to 1. If f of -2 is -5, so do the same thing I did here. Go ahead and plot your points. If f of -2 is -5 and f of 1 equals 4, which of the following statements could be false? So I know that this is a continuous and differentiable function, so there's no sharp turns, corners, or anything like that, yeah? Does f prime have to equal 0? I mean, sorry, f of x. Does f of x at some point have to equal 0? Yeah. Does f prime? No. If I can draw one situation where the slope never equals 0, then that does not have to be true. It could be false. The function does have to equal 3 at some point, right? And then why does the derivative have to equal 3 at some point? Because how much do we rise? From -5 to +4? Isn't that 9? Yeah? And then from -2 to 1, isn't that 3? So if that's 9 over 3, then the average slope is 9, or 3, 9 over 3. And what theorem tells me that at some point the derivative has to actually equal 3? The one that says that the average slope at some point has to equal the actual, and average, another word for, yeah, the mean value theorem. Okay. Okay, number 4. If f is continuous for all x's between a and b and differentiable for x between a and b, which of the following could be false? If you're continuous and differentiable, at some point c, does the derivative equal the average rate of change of b minus fa or b minus a? Yeah, that's mean value theorem. Does f prime have to equal 0? No, they didn't tell me anything about what the actual numbers were. They just said it's continuous and differentiable. These kind of mark each other out of the running, you know what I mean? So they're mutually exclusive. And then the integral from a to b, well, if it's continuous, then you can find the area underneath it, right? Okay. The function f is continuous and differentiable on the closed interval from 0 to 4. The table above gives selected values of f on it. Which of the following statements must be true? The minimum value on the interval from 0 to 4 is 2. Does that have to be true? Here's what I know. I know that at 0 it goes through 2, right? I know that at 1 it goes through 3. And then I know at 2 it goes through 4. And then it goes back down, right? Okay. So, does the minimum value have to be 2? Well, if the minimum value has to be 2, then why doesn't the maximum value have to be 4? You know what I mean? So I feel like they cancel each other out. Does f prime, what does that mean? F prime is greater than 0. What does that mean to you? Sorry, I said f prime. F. What does that mean for f to be greater than 0? It's positive. Do I have to be positive all the way from 0 to 4, the function? Nope, I don't. Right? Does the derivative have to be negative all the way from 2 to 4? Nope, because if you increase it all, then you don't have a negative slope. So there exists a c for which f prime equals 0. Why does f prime at some point have to equal 0? I do have horizontal tangents, and I know for sure that I have them because I have points that have the average slope is horizontal, right? Or 0. Okay. So that one right there, mean value theorem. Okay. Let f of x equal the integral from 0 to x squared of sine of t. At how many points on the closed interval from 0 to square root of pi does the instantaneous rate of change of f equal the average rate of change of f on the interval? Okay, so what is the instantaneous rate of change of f? What does that mean? Find the what? Rate of change? It means I'm going to take the derivative, right? Okay, so I'm going to take the derivative of this function. So I'm going to find f prime. Well, if f equals the integral from 0 to x squared of sine t, then what's f prime? Times? Okay. And then what's the average rate of change? Is this slope? Okay. So I'm thinking f of the square root of pi minus f of 0 over the square root of pi minus 0. Yeah? Okay, so if I plug in f of the square root of pi, f of the square root of pi equals the integral from the square root of pi squared of sine of t dt, right? So what's the derivative, or well, no, it's just that, right? So that's the integral from 0 to pi of sine of t dt, which I could find, minus the integral from 0 to 0. What's the integral from 0 to 0? Okay, so that goes away over the square root of pi. So my question is, at how many points does the instantaneous rate of change, this, equal the average rate of change, this? So if this is a calculator question, what would you do right now with this expression? Yeah, I'd probably graph. So I'd go to y equals, and I'm going to graph 2x sine of x squared, 2x sine x squared. And then in this one, I'm going to type in this integral. So from 0 to pi of sine of x dx, and then I'm going to divide by square root of pi. Okay. Do I need to change my window? 0 to what? Square root of pi. And then I'm going to go from -2 to 2. Well, I don't know. I might need to go higher, but we'll see. So how many times do these two functions equal each other? Okay, so I'm going to go up higher. When you graph an integral, it's having to think the whole time. So it probably would have been smarter to actually take the antiderivative sign. What's the antiderivative sign? Negative cosine of pi minus a negative cosine of 0, because it's a negative cosine of t evaluated from 0 to pi, right? What's negative cosine of pi? And that's plus 1, so 2 divided by square root of pi. Probably would have been easier if I just said 2 divided by square root of pi. As it is, I'm pretty sure it's going to be 2 as my answer, right? So if I had just 2 divided by the square root of pi. Yep. Okay. So we're good. As long as you are clear on what you should have done. It was kind of a weird question because it had this integral, this function defined as an integral, and it said, at how many points is on the closed interval does the instantaneous rate of change of the derivative equal to average rate of change, which is the f of b minus f over b minus a. Okay. So let f be the function defined by this. What is the value of c for which the instantaneous rate of change at c is equal to the average rate of change over the interval from 1 to 4? So they want to know for what value the mean value theorem is true from 1 to 4, right? So what does mean value theorem say? And what does that have to equal? Which is? Okay. So let's plug in 4. So I've got 4 plus ln of 4 minus 1 plus ln of 1 over 3. And that equals, what's f prime? So 1 plus 1 over x. Okay. So what do you know about ln of 4 or ln of 1? Ln of 1 is 0. So that's gone. I've got 4 minus 1, that's 3. So I've got 3 plus ln of 4 over 3 equals 1 plus 1 over x. Now you could simplify, you could start graphing, you could say I'm going to graph this, I'm going to graph that, see how many times they intersect or where they intersect, right? You could subtract 1 and then graph that. You could subtract this all from over there and set it equal to 0. Do you recognize that you could split this up and say 1 plus ln of 4 over 3 equals 1 plus 1 over x? Does that make sense? So then the 1's cancel out because you have a minus 1, they both cancel out, and then you're just asking yourself this, which if you have ln of 4 over 3 equals 1 over x, can't you just multiply by x and then divide by ln of 4? And say x over 3 equals 1 over ln of 4 multiplied by 3, and you got it? Whatever 3 divided by the ln of 4 is, right? Okay. But as far as like having a calculator, I'd probably just graph that. Or I would ask my 89 to solve that equation. Because it would do it. Okay. If f of x equals the integral from 0 to x of the square root of t cubed plus 1 dt, then f prime of 2 equals what? So they're asking me to find the derivative and then plug in 2. So what's the derivative of the integral from 0 to x? Uh-huh. When you take the derivative of an integral from a constant to a variable, all you gotta do is plug it in. So f prime equals the square root of x cubed plus 1. I want to find f prime at 2. So what do you get? There you go. 2 to the third, 8 plus 1, 9, square root of 9 is 3. And there you go. Okay, so same type thing. Slightly different. Let's do number 10. So what do we plug in? Plug in x squared where? Into t. So that's going to be x squared cubed, which is x to the 6th, yeah? And it's going to be a sign, yeah? Okay, so is it this one or is it C or is it E? You got to multiply by, don't forget to multiply by the derivative, right? So it's sine of x squared cubed, but then multiply by the derivative of the inside, which is 2x. Okay. Okay. For 0 to 60, must there be a time when velocity equals negative 5? Why? And where? Okay, so I would say velocity at 35 is less than negative 5, which is less than, hey, velocity at 50, yeah? Which is 0. What are you doing? Nothing? What are y'all doing up here? What are you going to ask me?
Do you want to go on a helicopter ride with us?
A helicopter ride? I can't. I'm making a video.
This is familiar. This is Mr. Bennett. Say hello.
Nice to meet you.
So, we're interrupting class because